Hi, aircraft instrument teardown today from a former TWA aircraft. As you can see, we have here a turbine gas temperature indicator up to 1200 degrees Celsius. So and it is from Lockheed 1011. I got this many years ago on US eBay. I believe it was one of my first ever purchase in the US via eBay. So it is called an indicator APU turbine gas temperature. So it is for the auxiliary power unit turbine. Made by there is a Lockheed reference, but it is made by Weston. A huge serial number here. We may have in fact September 1972 on serial number 18. It is possible. There is the model for the lamp if you want to replace it, and it is made by Western Instrument Division in Newark, New Jersey, USA. Here we have interesting information, TWA part number and serial number 6 only, and then the box you have to use to clip this instrument. On the front, just the needle indicator. The needle is made of plastic, so it must be backlit as your car dash indicators. And I see a little bit of play in the needle when I check. It is interesting. There is some kind of a push button here with a missing cap. And we have this piece, which is the backlight. 3 little bulbs mounted on this piece you can pull out with 2 contacts, and it looks like the bulbs are all perfectly blown. Okay, now I will open it. So if I remember correctly, I need to open it with removing the screws all around, only enough. I have a number of screws distributed all around, little Phillips screws, imperial thread of course, 2 more of them here. You can see one was hidden behind this sticker in fact, and I do not remember if it is me or not, but the sticker was cut to access the screw. Okay, so now I should be able to pull the thing. I did not miss anyone, no. Yes, here we are. So first the case is one aluminum piece. I do not see any weld in this. There is a part number stamp inside here. I really wonder how they did do for applying the stamp. Quite thin aluminium, not even maybe 1 mm thick. Even a little bit less, 0.7 or something like this. Okay, and inside the instrument we have this back plate with a connector, standoffs, 2 PCBs, main bakelite piece here to hold the galvanometer movement, and the front panel piece with here you have 2 contacts for the set of bulbs, like so, which will shine inside this clear plastic piece everywhere to light either the dial and the needle. So the movement is a simple galvanometer, as you can see, quite well shielded, but it is a galvanometer. You can see the return spring here in the middle, and here also you can see the back side of it. And you have two circuit boards. So this thing in the front, yes, it is a push button, as you can see. It will actuate this momentary push button mounted on the PCB. We have probably operational amplifier, yes, 741 in metal can. Very simple single-sided PCB, one trimmer, few resistors, capacitors. Here, not sure if it is a power supply section, maybe because we have a small transformer, but only two terminals on it, so it is just a inductor in fact. A few transistors and sealed mill grade capacitor, which is by the way glued with some goop on the PCB, as you can see here, and a glass insulator at the end, welded case. Interesting big resistor here with value written on it in numbers, and 3 transistors in metal cans, 2N series, 2N3053 for this one. Back piece is just aluminum plate. You can see the connector, back of the connector with wire soldered to it. There is some kind of rubber seal here, very sticky, and grounding here made of this piece, which is the receptacle for the screw. The connector itself, it seems it is welded in some way to the back piece, and you can see we have golden contacts. It is made by Dutch, it is a quite famous brand of connectors. Golden contacts here, rubber insulator piece here, but at the other side it seems we have some white glass or ceramic insulator. Quite interesting, and it is solder terminals, no crimped terminals. Okay, in fact it is all what we have in this. So probably it should be possible to reverse engineer it and try to drive it, but most luckily you will not need all this electronics, and you could drive directly the galvanometer if you want. Right, I believe we must have quite strong magnets somewhere in here, but it is a wall magnetic shielding here. Okay, on the glass on the front, I can see a pretty thick front piece in fact. And the glass is in some way attached to it, but I do not see anything you can undo to replace the glass. So quite interesting how they did do it. There must be a seal. Oh yes, maybe here. I see a gap here. So I'm not sure if it was welded or glued or anything. Yes, there is definitely a gap in here. So this front piece is added in some way. Okay, so I hope you did enjoy this detailed teardown. Thanks for watching. Bye bye.